Top 25 SRE Interview Questions and Answers. This guide provides essential site reliability engineering interview questions and detailed answers to help candidates understand key concepts, demonstrate capability, and prepare confidently for competitive SRE roles. 1. What is the role of a site reliability engineer? A site reliability engineer ensures systems are reliable, scalable, and high-performing by combining software engineering with operational practices. They automate manual processes, monitor system health, and manage incident response. SREs focus heavily on improving availability, performance, and efficiency. Their responsibilities include capacity planning, implementing SLIs and SLOs, reducing toil, and preventing outages through proactive engineering. They bridge development and operations, ensuring seamless deployments and long-term reliability across services. 2. What are SLIs, SLOs, and SLAs in SRE? SLIs, SLOs, and SLAs define reliability standards. An SLI measures a specific performance metric, such as latency or availability. An SLO sets the target for that metric, like 99.9% uptime. An SLA is a formal contract with penalties if targets aren't met. Together, they guide system reliability goals, ensure accountability, and help teams maintain balanced performance without over-engineering. These metrics provide clarity, consistency, and direction for engineering and operational decisions. 3. What is an error budget and why is it important? An error budget represents the allowable amount of failure within an SLO, helping teams balance innovation with reliability. If the error budget is exhausted, feature releases pause, and stability becomes the focus. When there is remaining budget, teams can deploy faster. Error budgets prevent over-engineering, encourage healthy risk-taking, and align development and reliability goals. They ensure teams prioritize reliability appropriately, making decisions based on measurable performance data rather than assumptions. 4. What is toil and how do SREs reduce it? Toil is repetitive, manual, and automatable operational work that does not create long-term value. Excessive toil leads to burnout and inefficiency. SREs aim to keep toil below 50% of their workload by automating tasks, improving tooling, refining processes, and eliminating unnecessary manual steps. By reducing toil, teams focus more on engineering improvements, reliability innovation, and strategic work. Effective toil reduction enhances productivity, system stability, and job satisfaction across large-scale environments. 5. How do you handle incident management as an SRE? Effective incident management involves rapid detection, clear communication, and systematic resolution. SREs use monitoring dashboards, automated alerts, and runbooks to respond quickly. They prioritize restoring service before diagnosing root causes. After incidents, they conduct blameless postmortems to understand failures, improve processes, and prevent recurrence. SREs collaborate across teams, maintaining transparency and focusing on customer impact. The goal is minimizing downtime while strengthening reliability through continuous learning and proactive improvements. 6. What monitoring principles do SREs follow? SREs apply monitoring principles focused on actionable insights, not noise. They track golden signals, latency, traffic, errors, and saturation. Monitoring ensures systems function correctly and alerts trigger only when necessary. SREs design dashboards to highlight anomalies and prioritize customer-facing impacts. They choose meaningful thresholds, avoid alert fatigue, and automate detection processes. Good monitoring helps maintain reliability, supports diagnostics, and forms the foundation for fast incident response and effective long-term capacity planning. 7. What are the 4 golden signals and why are they important? The 4 golden signals, latency, traffic, errors, and saturation, provide essential visibility into system health. Latency measures request time. Traffic indicates demand. Errors capture failures. Saturation reflects resource limits. Monitoring these signals helps detect issues early, assess performance, and prioritize incidents. They simplify complex systems into key metrics that reveal bottlenecks and user impact. SREs rely on golden signals to maintain reliability and create consistent, effective alerting strategies across distributed applications. 8. How do you perform capacity planning in SRE? Capacity planning ensures systems can handle future load without performance issues. SREs analyze historical data, model growth patterns, test system limits, and plan required resources. They collaborate with product teams to understand upcoming features and expected user behavior. Capacity plans prevent outages caused by resource exhaustion. SREs regularly validate assumptions, simulate peak scenarios, and adjust infrastructure to maintain efficiency. This proactive approach improves scalability, availability, and long-term cost optimization. 9. What is chaos engineering and how is it applied? Chaos engineering involves deliberately injecting controlled failures into systems to test resilience. SREs use tools like Chaos Monkey to disrupt services, networks, or resources. The goal is identifying weaknesses before real incidents occur. Experiments are carefully planned, monitored, and evaluated through measurable outcomes. This practice improves reliability, validates assumptions, and strengthens failover mechanisms. Chaos engineering ensures systems behave predictably under stress, enabling teams to build robust, fault-tolerant architectures. 10. How do you approach reducing mean time to recovery (MTTR)? Reducing MTTR requires rapid detection, efficient troubleshooting, and clear communication. SREs implement strong monitoring, reliable alerts, and detailed runbooks to speed diagnosis. Automation helps restore service quickly, while well-designed architectures support graceful degradation. Collaboration among teams ensures fast decision-making. Post-incident reviews highlight improvement areas. Consistently reducing MTTR strengthens user experience, minimizes downtime, and boosts overall service reliability. The key is preparedness, automation, and continuously improving operational processes. 11. What is a blameless postmortem and why is it important? A blameless postmortem analyzes incidents without assigning personal blame. It encourages transparency, honesty, and continuous learning. SREs document what happened, why, and how to prevent recurrence. This approach strengthens organizational culture, reduces fear, and fosters collaboration. Blameless postmortems produce practical remediation plans, helping teams improve reliability over time. They turn failures into opportunities to enhance processes, tooling, and overall service resilience. 12. How do you implement automation in SRE workflows? Automation eliminates repetitive tasks, reduces toil, and improves reliability. SREs automate deployments, monitoring, incident response, scaling, and configuration management using tools like Terraform, Ansible, and Kubernetes. Automation ensures consistency, reduces human error, and supports faster operations. Before automating, SREs analyze processes to identify optimization opportunities. Automated workflows integrate with CI/CD pipelines to enforce best practices. Ultimately, automation empowers teams to focus on engineering improvements and long-term stability instead of manual operations. 13. What is infrastructure as code and why is it important? Infrastructure as code manages infrastructure through declarative or scripted files, ensuring consistency, version control, and reproducibility. Tools like Terraform and CloudFormation automate provisioning, scaling, and configuration. IAC reduces manual errors, accelerates deployments, and enables rapid recovery by rebuilding environments quickly. It supports collaboration, auditability, and standardized environments across development and production. By treating infrastructure like software, SREs enhance reliability, agility, and control over complex, distributed system configurations. 14. How do SREs work with development teams? SREs collaborate closely with developers to ensure systems are reliable, scalable, and high-performing. They provide feedback on architecture, share operational insights, and support improvements in code quality. SREs help define SLIs, SLOs, and reliability targets. They collaborate on deployments, automate processes, and assist in resolving production issues. This partnership fosters shared ownership and encourages engineering decisions that enhance reliability. Effective collaboration creates a culture where stability and innovation coexist harmoniously. 15. What is the difference between DevOps and SRE? DevOps is a philosophy that promotes collaboration between development and operations, while SRE is a concrete implementation of those principles using engineering solutions. DevOps focuses on culture and practices, whereas SRE applies metrics, automation, and reliability targets. SRE introduces concepts like error budgets and SLOs to guide decision-making. While both aim for faster, more reliable delivery, SRE provides a more structured, measurable, and engineering-driven approach to reliability and operational efficiency. 16. How do you prioritize reliability versus feature delivery? SREs balance reliability and innovation using error budgets. When error budget remains, teams can release features more freely. When it's exhausted, reliability becomes the priority. Decisions rely on SLO performance, business impact, and risk assessment. Clear communication between SREs and developers ensures alignment. This approach prevents excessive downtime, avoids over-engineering, and maintains user trust. Prioritizing reliability appropriately ensures sustainable growth, effective planning, and consistent service performance regardless of evolving product roadmaps. 17. What logging strategies are effective for SRE? Effective logging strategies include structured logs, centralized storage, and meaningful log levels. SREs ensure logs contain actionable data, such as timestamps, request identifiers, and error context. Tools like ELK Stack and cloud logging centralize analysis. Log retention policies prevent unnecessary costs. SREs avoid excessive verbosity while ensuring adequate detail for debugging. Good logging supports faster incident response, improved diagnostics, and clear visibility into historical events, strengthening long-term operational reliability. 18. How do you conduct root cause analysis in SRE? Root cause analysis identifies the underlying reasons behind incidents. SREs begin by collecting logs, metrics, timelines, and system behaviors. They recreate failure scenarios when possible and evaluate contributing factors. Techniques like the 5 whys or fishbone diagrams help isolate root issues. RCA avoids blame and focuses on systemic improvements. Findings inform action items, architectural adjustments, and process enhancements. The goal is preventing recurrence and strengthening reliability across complex distributed systems. 19. What are common SRE tools and technologies? Common SRE tools include Kubernetes for orchestration, Prometheus and Grafana for monitoring, Terraform for infrastructure as code, Ansible for configuration, and Jenkins for CI/CD logging. Platforms like ELK Stack provide observability. Cloud services such as AWS, GCP, and Azure support scalability. Incident response tools like PagerDuty streamline alerts. These technologies automate workflows, improve system visibility, and enhance reliability. SREs select tools that align with organizational needs, scalability goals, and operational workflows. 20. How do you ensure high availability in distributed systems? High availability requires redundancy, failover mechanisms, load balancing, and resilient architecture. SREs design systems that continue operating despite failures. Techniques include multi-zone deployments, health checks, auto-scaling, and graceful degradation. Monitoring detects issues early, while automation ensures rapid recovery. SREs also implement chaos testing to validate resilience. Well-planned capacity, distributed services, and fault-tolerant components help maintain consistent uptime. High availability ensures minimal disruption and supports strong user experience across large platforms. 21. What is blue-green and canary deployment strategy? Blue-green deployments switch traffic between two identical environments to ensure safe releases. Canary deployments gradually roll out changes to a small user subset before full release, reducing risk. These strategies allow quick rollback if issues arise. SREs use them to minimize downtime, validate performance, and ensure stable releases. Automated monitoring detects anomalies early. Both approaches enhance reliability, reduce deployment stress, and enable rapid recovery from unforeseen deployment-related failures. 22. How do you design reliable alerting systems? Reliable alerting focuses on actionable, meaningful alerts with minimal noise. SREs define proper thresholds, prioritize user-impacting issues, and group-related alerts. They use SLIs and golden signals to guide alert rules. On-call schedules ensure balanced workloads and responsiveness. Effective alerting prevents fatigue, accelerates response, and ensures critical issues receive timely attention. Continuous tuning of alerts improves accuracy. The goal is delivering the right alert, to the right person, at the right moment. 23. How do you ensure security in SRE practices? Security in SRE practices includes enforcing least privilege access, applying infrastructure as code, monitoring anomalies, and automating patching. SREs work with security teams to implement policies, protect secrets, and ensure compliance. They use secure CI/CD pipelines, encryption, and vulnerability scans. Regular audits and incident simulations strengthen readiness. Integrating security into reliability work ensures systems remain resilient not only to technical failures but also to malicious threats across distributed environments. 24. What is the importance of observability in SRE? Observability allows SREs to understand internal system behavior through metrics, logs, and traces. It goes beyond monitoring by answering why systems behave unexpectedly. Good observability tools help diagnose issues faster, improve reliability, and support complex architectures like microservices. Observability enables predictive insights, reduces MTTR, and strengthens performance optimization. It helps build robust systems by uncovering hidden dependencies and providing deep visibility into distributed interactions throughout the entire service lifecycle. 25. How do you build a culture of reliability in an organization? Building a reliability culture requires shared ownership, transparency, and proactive practices. SREs promote blameless postmortems, measurable SLOs, automation, and continuous improvement. Leadership support ensures reliability becomes a strategic priority. Cross-team collaboration strengthens communication and shared responsibility. Encouraging experimentation, reducing fear of failure, and celebrating improvements fosters growth. A strong culture aligns engineering practices with business goals, ensuring long-term reliability, customer satisfaction, and scalable system success across the organization. These SRE interview questions and answers provide structured insights to help candidates master reliability concepts, demonstrate expertise confidently, and prepare effectively for competitive site reliability engineering roles.